Now, today let us discuss this second part of mixed game, because last video we have discussed 2 cross 2 mixed game, but now we are discussing the bigger one. That means more strategies for A and B. It may be 3 rows, 3 columns, or 3 rows, 4 columns, or 5 rows, 3 columns, anything. Not 2 rows, 2 columns. 2 rows, 2 columns, that means 2 cross 2 game in the case of mixed game is compulsorily required. It has to be 2 rows, 2 columns at the end. Before getting the final answer, we have to finally get the 2 rows, 2 columns game. But in the question, we might find practical say that A may have more than 2 strategies and B has more than 2 strategies. That means now we are considering M cross N game, where both M and N greater than 2. Both M and N both are greater than 2. That means it will be bigger one. The main target in this case, our target will be to reduce this M cross N game to 2 cross 2 game. That means reducing the bigger matrix to 2 cross 2 matrix. There are many methods. Today, this video I want to discuss dominance principle. If you just remember one thing, you can easily remember this idea. A always try to maximize his profit. So A strategies should be those strategies which are more, values are more, and B's concept will be to reduce the loss. That means B's strategy will be to get less or lower loss. So A is trying to maximize his profit, and B on the other hand wants to minimize his loss. So this is the main idea behind the dominance principle. So along the row we will apply row dominance principle this way, that if all values of any row greater than equal to all values of any row greater than equal to any other values, corresponding values of any other row, all values of any row greater than equal to, it may be greater than, it may be equal to corresponding values of other row, then this row which has the bigger values will dominate the latter row. So in the concept of row dominance, our idea will be to take the bigger row, or which some values may be equal. That means if x denotes the values of a row greater than or equal to y, another row's value, then we will take the row having the values x. So x greater than or equal to y, then we will choose x. That means row having x will be chosen. It will be dominated. It will be dominating row, and dominated row will be the lower values. So the bigger values, the row having bigger values will be chosen, and the smaller value, the row having the smaller value will be deleted. That means dominated means, dominance means the bigger values, the row having the bigger values will be chosen, and the row having the smaller value will be deleted. This is the row dominance. Now come to column dominance. Obviously, I discussed this way. Row means the profits of A. So that will be maximum. So when we are discussing column wise, column values, the values along the columns always denote the loss of B. So our target will be the reverse. That means all values of any column less than or equal to other column, that of other column, corresponding values of other column, then the column having lower value will dominate the higher value. So in column dominance, the columns having the lower value will dominate the column having higher value, and in the case of row dominance, the row dominance principle will be the row having the higher value or equal to value than other rows will be dominating than the other one. So it will be the lower value, the column having the lower value will be chosen, and the column having higher value will be deleted. That means here it will be x less than equal to y, then x will be chosen. X means the values of the column and y other column's value, but here we will choose x when x is smaller. In the case of row dominance, x greater than equal to y, then we will choose x, because we are choosing the profit in the row ideas and loss in the case of column. Another concept we also remember, very rarely we will apply, not always, sometime, that is average dominance. This average dominance principle sometime we need, that is average sometime. If you can, we cannot apply any dominance principle, that we cannot reduce the matrix applying this dominance, then we can sometime apply the average concept. The average of 2 rows or 3 rows, average of values of 2 or 3 rows, 2 or 3 rows, 2 or more rows, better it will be 2 or more rows, if greater than or equal to other values of other row, greater than or equal to values of any other row, then these rows whose values average we have taken will dominate the latter row. That means then latter row will be dominated. Latter row means the row having the smaller will be deleted or dominated. Will be dominated means deleted. What is the meaning of the word dominated? Means it will be deleted. That means if I find R2 and R3, these two rows, if I take the average, find that it is greater than equal to the values of R1, then we will delete R1, because R2 and R3 combined effect is more than that of the first strategy or first row. So in the case of row dominance, taking the average, we will take the average of 2 or 3 rows and compare with the remaining row, and if we find that average values are greater than or equal to the corresponding values of the remaining row, then the remaining row whose values are lower, then average values of the those rows whose average we have taken will be chosen, and the smaller one will be deleted. The reverse concept will apply in the case of column, that means average of 2 or more columns. In the case of columns, we will get the similar concept. Average of 2 or more columns. If not greater, it will be column wise, we always think about the losses. If less than or equal to, is less than or equal to values, that means corresponding values of any other column, then the latter column will be deleted, that means dominated. That means if I find C1 and suppose C3, these two average is less than equals to C2. That means what we are finding, that first column and third column values are added and we are getting an average by 2. The values what we are finding about in this average calculation are all less than equals to the corresponding values of the second column. The second column will be deleted because first and third column has the lower values given in the average values. So that is average dominance. It is very rarely applied, very extreme cases we apply. If we cannot apply dominance principle, then we choose the idea of average dominance. Now come to one example. Mostly we apply row and column dominance. It will be said like this: solve the game. Solve the game. Mostly they don't say the method, that solve the game by dominance or algebraic method. Nothing is mentioned. Just solve the game. And the strategies of B and strategies of A are given. B1, B2, B3, B4. 4 strategies we are finding for D. On the other hand, A has also only 3. A does not have 4, it has 3 strategies. And now we are getting the values this way. These are the values of the game according to the corresponding strategies. Now what we find that it is obviously more than 2 rows 2 columns, but before starting we should check one thing. What we will choose, what we will find. First thing, what to do. First thing, before solving any game, this is a big 3 cross 4 game. This game is 3 cross 4, means 3 rows for A and 4 columns for B. First thing, saddle point. What is the minimum value of the row? Minimum value of the first row is -2, second row is -1, third row is -3. So these are the minimum value of the rows. What is the maximum value for this one? Maximum value is -1. So what we are finding, that maximum is -1. Now come to the maximum values of the columns. What are the values of the columns? First column is maximum is 4, second column is 7, third column is 5 and fourth column is 4. So 8. Fourth column is 8. So what is the minimum among this maximum value? This is the 4. So what you are finding? No saddle point, -1 and +4. So maximum is -1 and minimax is 4. So we have no scope to have the result. It is a mixed game. It is not a pure game. Means we have to find the probabilities of these strategies of A1, A2, A3's probability, and B1, B2, B3, B4. These probabilities we have to find. But in our normal questions, always we have to reduce the matrix to 2 rows, 2 columns. Now let us observe and check the matrix once more. What is the matrix? 1, 7, -2, 8. Then this is first row, that is A1. 1, 7, this is A1, and A2 has 4, -1, 5, 3, and A3 has 2, 3, -3, 4, and B1 like this, B2 like this, B3 and B4. Now let us try to reduce the matrix using dominance principle. This is the target, how to reduce a bigger matrix to a smaller matrix 2 cross 2. Now try. What you are trying there? Maybe some students trying with row, some students trying with column. There is no such fixed rule which side we will start. What I am finding in this case, that if you watch the second column and first column and the second column, what you are finding that column wise, this whole matrix, what we are finding is like 1 is less than -2 is less than this way. Yes, 7 is less than 8, -1 is less than 3 and 3 is less than 4. That means what you are finding, that second column is obviously less than 7 is less than 8, -1 is less than 3 and 3 is less than 4. So what we are finding, that second column is lower than the fourth column. So we will remove the fourth column, because fourth column shows more loss. So the reduced matrix, that is, we have to mention that B2 dominates B4. B2 dominates B4 because B2 has lower values. So 1, 7, -2. This is B1, B2 and B3. Because B4 is deleted. B2 has dominated B4. Then 4 -1, 5, 2, 3, -3. This is A1, this is A2, this is A3. This is the idea of dominance, to reduce the matrix by any method such a way that we will be able to get the smaller one. Now in this case, what you are finding, that if can be reduced further, then only we can proceed to solve. Otherwise, we cannot have any scope to solve the problem because dominance principle only possible to apply to make the matrix as 2 cross 2 matrix. In this case, what we are finding that other values, if you observe the other values, then what you are finding is of course, if you take the average of first two, there may be other ideas. 1, 4, average is 5 by 2, 2.5. So if you take the average of A1, A2, I am not telling that you must take the average. Just I am wanting to show what is the meaning of average dominance. Because I told you column dominance means the lower values. The column having the lower values will dominate the higher values. So lower value columns will be taken. In the case of row, we will take the higher one. Let us take the average of these two. When you are taking the average of A1 and A2, what are the values we are getting? Average means 1 plus 4 by 2. Then 7 minus 1 by 3, 2. And minus 2 plus 5 by 2. So what is the average? This 2, average 2.5, then it is 3, and then it is 1.5. Now let us compare 2.5 to more than 2. 2.5 is A2 and A1. A1 and A2 is average. This 2.5 is more than 2. 3 equal to 3 and 1.5 is obviously greater than minus 3. So A1 A2's combined average value is greater than that of the third row, that means A3. So we will remove A3 because now we are applying average dominance. I am telling you this can be other way solved, but just I am wanting to show what are the concept of dominance. When you can directly apply the row dominance or column dominance, it can be easily chosen. But I have one thought in my mind that I want to show different ideas. This is the average concept. So what you are getting, it will be now 1 and 2. That means A1, A2. This is the reduced matrix. A1, A2. Now we are having reduced matrix. So this is the reduced matrix. Originally it was 3 rows, 4 columns. Now after applying the dominance principle, we are getting the matrix gradually reduced. Now let us see what we are finding that in this case, if we can reduce the matrix to smaller one, 2 cross 2, then only we can solve the problem. Otherwise, we have no scope to solve the problem. That is we can solve, but other method. Only when we can reach 2 rows, 2 columns, then only we can solve this problem. But if you look at this situation, there is a problem in this situation that no row can dominate because this 1 is of course less, so 4 is bigger, but 7 is bigger, so we cannot apply row dominance. Row means any row should be greater than other row, and column wise any column individual values should be less than other values. So 1 is not less than 7, 1 is less than 7, but 4 is not less than minus 1, 1 is not less than minus 1 is not less than minus 2, that means minus 2 is smaller, but 5 is bigger. So there is the problem. This is reduced matrix. So one thing I am wanting to do, this problem I am wanting to keep for next topic. I have discussed this problem so that we can understand how to reduce a bigger matrix to a smaller matrix. This reduced matrix is now 2 rows, 3 columns. So we failed to change the problem as 2 rows, 2 columns matrix. Therefore, our target to apply only dominance principle fails. Our next target will be to learn graphical method that I will be discussing next video. Today I am just wanting to show you how to change a bigger matrix to a smaller matrix applying dominance. There are 3 types of dominance. One is row, another is column, and the other one under compulsion, sometime we apply average dominance to get the matrix reduced. But if you cannot reach 2 rows, 2 columns, then the problem cannot be solved because you have to have 2 rows, 2 columns. And then if it is the case that 2 rows, 2 columns cannot be reached, 2 rows, 3 columns, or 2 rows, 5 columns, or 5 rows, 2 columns, 6 rows 2 columns like this. This means 2 rows more column or more rows 2 columns. This idea we will be discussing in graphical. So this problem I am leaving. That means graphical method to be applied, which is the next concept which we will be discussing next video. This will be requiring graphical method. Why I have given this example? To explain that when a question to be solved in game, we have to start first thing to check whether it is a pure game or a mixed game. If the game is pure game, then what we do, we have to reduce the game, the saddle point checking and get the answer. But if it is a mixed game, we have to reduce the game to 2 rows 2 columns, because very rarely the question will be given 2 rows 2 columns. Now let us take, so what is the answer to this question? I am keeping this question for the next class, that will be next video when I will discuss the idea of game by graphical. But now I am wanting to do another problem using, like I am mentioning, dominance principle. If this is mentioned, using dominance principle solve. So what is the difference? In the previous case, I have not mentioned that name of the method. Last problem I can say this is not completed. We will complete that problem next time. But for the time being, we are learning how to apply dominance principle. Dominance principle is mentioned in the question. Using dominance principle solve the game. The question is like this: B1, B2, B3. These are the 3 strategies for B, and A has also 3 strategies: A1, A2, A3. So what you are finding, that 3 rows 3 columns we are having in this case, and the values are 1, 7, 2, 6, 2, 7 and 5, 1, 6. Now I suggest you that when the method is mentioned, don't try to judge whether it is pure game or mixed game, because it is clearly mentioned that you apply dominance principle. So we will directly start with the idea of dominance. Now if we look at the problem, what we are finding, that A1, A2, A3. A1, A2, A3. Look, A2 and A3, compare. I am not telling, I am telling you that you can start any way you like. Since here I am observing that row 2, that means A2, row 2, 6 bigger than 5, 2 bigger than 1 and 7 bigger than 6. So in row dominance, our target will be to have the row having more values. So second row have the values, has the values 6 greater than 5, 2 greater than 1 and 7 greater than 6. So A2 is bigger than A3. So A2 second row dominates A3. That means A3 will be deleted. My target is to teach you, to give you the idea how to apply the dominance principle. Because I have already mentioned, when you will reach 2 rows 2 columns, then we can solve the problem. In the previous question, I failed to reach 2 rows 2 columns. But now I am trying to solve a problem when we will be finally able to reach 2 rows 2 columns. That is the main target of mixed game. So 2, A2, that is second row dominates the third row. So reduced matrix B1, B2 and B3, and A1, A2 will be there, 1, 7, 2, 6, 2, 7. Now we will see. What will be seeing? Look, 1, 2, first column and third column, 6, 7, 1, 2, 6, 7. So if I compare the first column, this 1, 6 with third column 2, 7, what we are observing, that column wise, now we are finding that column wise, first column B1 is obviously less than equals to B3. That means all the values of the first column are equal or less. Here it is not a question of equality. 1 is less than, actually it is less than. So B1 strategy are lower. So in the row we have seen the values higher are important. And in the column wise, the values lower will be important. So B1 will be dominating B3. So B1 will dominate B3. Therefore B1 will be there, B3 will be deleted. That means we are now reducing the matrix further. This is the idea of how to reduce a bigger matrix to smaller matrix. Last problem also I have shown. But finally we could not reach 2 rows, 2 columns. Now in this case, you watch. Last problem I have not solved. I'll solve next time. But this problem in loop, we have ultimately solving, that means reducing to 2 rows, 2 columns. Because B1 dominating B3, that means B1 will be chosen, B3 will be removed. So this is the final idea, because now we have very easy task to do. What are the chances of A1, A2 and what are the chances of B1, B2? So any problem of game, your first target will be, if nothing is mentioned about the method, you start checking saddle point. If saddle point is not there, then you check mixed game. That means how to reduce the bigger matrix to smaller matrix. First and the most important target, row dominance, column dominance, any one you apply, or average dominance. It may be row wise, it may be column wise, and finally to get a smaller matrix, 2 rows, 2 columns. In the previous case we failed, but next video will show that there is another method called graphical method to reduce the matrix to 2 rows, 2 columns. In this case, it is clearly 2 rows, 2 columns. Now how to find out? That probability of A1 is P. What is the value? What is the formula? Just previous video I showed. 2 minus 6. The idea is 2 minus 6. A22 minus A21. That is 2 minus 6 divided by 1 plus 2. 1 plus 2 minus 6 plus 7. Idea is very simple. To get the probability, you can find very simply. So it is minus 4 in the numerator and denominator is minus 10. Because minus 3, this is plus 3 and this is minus 13. So 2 by 5 is the probability of A1. Therefore, what is the probability of A2? That will be 1 minus P. So A2's probability is 3 by 5. Now, what is the probability of B1? What is the probability of B1? Very easily we can find. B1 probability we say Q and the value will be 2 minus 7. 2 minus 7. When we find P, we move horizontally. When we find Q, we move vertically. That is 2 minus 7 divided by 1 plus 2. The same idea. Minus 6 plus 7. So what you are finding? Q, the value of Q is minus 5 divided by minus 10. Minus 5 divided by minus 10 and the value is Q is half. So what you are observing here, finding the probability of P, that is A1, we are getting 2 by 5, to A2's probability will be 3 by 5. And B1's probability is half. Obviously, B2 probability is also half. Now what is the value, optimum value of the game? Optimum value means the best value of the game. 1 into 2. In the numerator we will multiply minus 6 into 7 divided by 1 plus 2. Very simple. This into this minus this into this divided by this plus this minus this plus this. So easily we can solve, and the result is 2 minus 42 divided by 3 minus 13. So 40 minus divided by minus 10. So answer is 4. So what is the final answer to the game? Any question, even it is not mentioned, even if it is not mentioned, apply dominance principle, then you will first check the saddle point. If there is saddle point, answer is easy. I don't think that the questions will be given where saddle point exists. That means the mixed game will be given. When the game is a mixed game, we start whether it is 2 cross 2. If it is not, then we proceed to dominance principle, reducing the matrix to 2 cross 2. If you cannot reduce 2 cross 2, it may be 2 cross 3 or 4 cross 3, 4 cross 2 or 2 cross 4. That means we cannot reach 2 rows, 2 columns. Then we will apply the other method, and the method is graphical method, and some other methods are also there. I will discuss in the next videos. Here we are giving the final answer to this question. What is the final answer? Probability, the value of the game is 4, and what are the probabilities of A? So probabilities of A will be A's probability. I can write this way. A's probabilities are A1 is P. Probability of A1 is P, and P probability is 2 by 5. Then A2 is 3 by 5. But A3 was deleted. Why it is 0? Probability of A1 we have chosen and calculated 2 by 5. Probability of A2 1 minus P. This is P, this is 1 minus P. And why this is 0? Because third row, that is A3, was dominated. That means it was deleted. So no chance. So P and 1 minus P for A's probability A1, A2 and A3 is 0. And what about B? B's case, what is the answer of B? B's case we have found that ultimately we are getting B1, B2. B1, B2 is half, half, and B3 ultimately we have found that B3 was dominated, so it is 0. So finally when we will give the answer, optimum value of the game is 4. A's chance will be 2 by 5, 3 by 5, 0. Mixed 2, 5, 3 by 5, 2 is to 3 ratio. 2 is to 3 ratio, A is mixing his strategies and A3 is not chosen. And B is mixing 1 is to 1. So this is the reason why we call the game to be mixed game. So that's all for game theories, mixed game when it is bigger. And how to reduce, I have given two examples. First example, I have shown some column dominance and average dominance. Although we cannot ultimately solve the final answer, we will learn the next video how to solve graphical, and the next problem I have shown how to solve a game ultimately to 2 plus 2 and then solve it. This is idea about game theory.